Hello everyone and welcome to ce721 for the spring term of 2021. Electronic systems design and integration. I guess it's probably mainly in the title. ce721 is a skills-based module. Now, what is a skills-based module versus an exams-based module and so on? It's all about bringing your skill set up so that you're employable in the workplace. Now, at the end of this, what we would hope students would be able to do is take an example circuit, produce a high-level, high-quality printed circuit board, and be in a position to have that populated with components and tested. In other words, the whole design cycle of PCB design from start to finish, and some of the analytics and testing that go along the way. So, just reading from the slides, the aim of the module is to introduce the fundamentals behind PCB design, procurement and population. So it's not just about designing the PCB. Obviously you've got to find the components and so on, and you've got to consider the ways in which those components are going to be put on the board. Throughout this course I'm going to be using Multisim as the exemplar. If you have experience in other simulators and PCB production software, then you can go down that route, but just beware, we may not be able to support you quite as well as we can with Multisim. So I'd strongly recommend you take the Multisim route. So students will experience the complete design cycle from description to testing. Due to COVID restrictions at the moment, a lot of that testing may be virtual. We may be online later in the term doing face-to-face, but at this point in time we're not entirely sure, but that's not going to interrupt our enjoyment of this module, hopefully. The module is 100% coursework based around 2 assignments, each worth 50% each. So just stating the obvious, there is no exam on this, it's just coursework. Now, of course, what that means is those 2 pieces of coursework are quite stringent. They're in the form of 2 essay type of responses, and I would expect to see a high quality PCB inside those reports and any tests and simulations that you've done on them. Guidelines for what's in the report, well, you can look on Moodle. There's quite a lot of material on Moodle about the reports, but obviously we'll discuss those as we go through the term as well. So main tools used, Multisim, absolutely. Multisim is owned or run by National Instruments. A tool that goes with it is Ultiboard, so you can export directly from Multisim into Ultiboard, which is also a National Instruments tool, and from that you can produce the PCB directly. Is Ultiboard the best PCB producer in the world? No, and I've used many others, but it's sufficient for what we want to do here. And the fact that you don't have to redesign your circuit, so you have to use a different platform to produce the PCB, we can just use Multisim and then link into Ultiboard, and most of the hard work's done. Some of the work that you do, it's quite nice to build a box or something, and we have SolidWorks on the Horizon server as well. So if you want to, you can build some housing or something like that. Again, we can discuss that later in the term. Everything you're going to access at the beginning of term will be remote access, and our Horizon server on the link below, so if you just click on that, it will ask for your username and password, and what that does is that puts you straight into a virtual computer as if you were sat in one of our labs. So clearly it's a nice position to be in. You have access to all of the high-end software, the software that costs lots of money basically, as if you were sat at the PC at the university. Now, there's no huge round-trip delays or anything like that. It works just as if you were sat in the university, and it took us most of the summer to try and sort that out. So that's working rather well at the moment, so the experience should be just as if you're in the lab. What will the assignments be? So they're the 2 main things, and students tend to, priority number 1 is pass the module. So design and test a solar tracker. What's a solar tracker? Do a little Google search on that and you'll see lots of interesting pictures. But basically a motorised electronic device that follows the sun. Now, why would you want to follow the sun? Well, if you turn a solar panel at 90 degrees to the sun, it's going to collect the maximum amount of energy it can. Now, this makes a surprising amount of difference, especially in the winter months, because if the sun's out and it's at 20-30 degrees, if you do the cosine of the angle, you'll find you're losing a lot of that energy because of the angle of the panel. Well, we're going to design a circuit which compensates for that, and it's only going to be a model, but nevertheless it could be scaled to a much larger case. The second assignment, a design of your own choice taken from reference. The one thing I would point out is you don't actually have to design from first principles in this module. It's perfectly reasonable, and this is what most electronic designers do anyway, to take an electronic circuit from reference that someone else has developed and described. You then implement it and perform the tests on it and so on. We've got lots and lots of examples on the Moodle page of the different types of circuit that you could use. Some of you who have some good imagination would probably want to take a circuit of their own, whereas others might feel a bit reluctant to make that decision, so ultimately they can just take a circuit, one of the ones that I've recommended. Both assignments should be fully documented and include the simulations, explanation of operation, which you can get from reference, and an associated printed circuit board, or PCB. Most likely to be double-sided PCB, and also in the assignment we would want some description of the files that you would need to send off to PCBWay, which is a Chinese manufacturer that we send off to, and PCBWay would want the files in a particular format before they could produce the PCB for you. Again, lots of stuff on that to follow. Each assignment is via a report, that's already been said, and each assignment is worth 50% of the overall of ce721. So everything to play for. We meet up 6 hours a week, so we're on 3 hours in the morning, 3 hours in the afternoon on Tuesdays. Do you have to attend all 6 hours? Actually no, because what's happened in the past, ce721 has been extremely popular, but there have been timetable clashes, so a couple of years ago, to solve this, I just added another 3 hours on. So fundamentally you probably only need to do about 3 hours a week on ce721, but nevertheless I will be there for 6 hours. So anyone that's got a timetable clash and is panicking that they're going to miss out on content, don't, because the contingency has already been made. Now, someone who's going to be helping you with this is my PhD student, shortly to graduate, Dr. Mike Walton, or will be Dr. Mike Walton, probably about halfway through the term, so you can celebrate with him probably in week 5 or something like that. Mike is an electronic designer by profession and has been for the last 20 years or more, so he designs a whole series of circuits according to customer specification, and has to get them right the first time, because otherwise he doesn't make any money. Okay, hopefully that's filled you in on some of the basics, and I look forward to seeing you subsequently in other videos. Thank you very much for joining me, and I'll speak to you soon.